Bismillahirrahmanirrahim. Assalamualaikum. My name is Tengku Fakhruddin Firdaus Bin Tengku Mohd Faris. In this presentation, I will do a project proposal for FYP1, by which my title is Design Review of Fire Rescue Tender FRT Water Tank Leakage Problem in Engineering Department JBPM Selangor. My supervisor is Dr. Helmi bin Rashid, Senior Lecturer in School of Mechanical Engineering, and my co-supervisor is Mr. Ahmad Firdaus bin Abdul Malek, Assistant Engineer in Engineering Department, Fire and Rescue Department in Selangor. The content for this presentation are background of study, literature review, problem statement, objectives, scope and limitation, methodology, expected results, and project planning. This study involves water tank leakage problem in fire truck, or best known as Fire Rescue Tender (FRT), that being used in JBPM. The model of the FRT is Kenya P310 as shown in figure 1. Meanwhile, fiber reinforced plastic or FRP tank that used in this model can carry up to 3,600 liters of water. According to Mr. Ahmad Firdaus, the water tank leaked at the bottom and edge part of the tank. It may due to friction between the FRT's mounting and the tank from the effect of inertia. Figure 3 shows the simulation of sloshing effect for diesel tanker. Acceleration and deceleration of the FRT with partially filled tank causes liquid slosh and surge that end up with the movement of the FRP water tank. To reduce the sloshing effect, baffle need to be installed in the tank. However, the water tank of the FRT Scania P310 uses solid baffle or non-porous baffle design, as shown in the figure 4. Next, we will continue to literature review for this study. First topic that related to this study is sloshing effect in a tanker. A total of 5 articles that related to this topic. Firstly, study by Junior Joseph E. Boone et al. In 2002 and F. Whitford et al. In 2011 stated that the slosh effect occurs when the tank is partially full, meaning that the liquid in the tank does not reach its maximum capacity. Secondly, research by S. Ali et al. In 2020 have found that when the level of water increases in the tank, the slosh effect increases but frequency decreases. Lastly, study by Lloyd et al. And Junior Joseph E. Boone et al. In 2002 have described the weight shift of liquid causes overpower brakes, affecting public and driver safety and the structural integrity of the tank. Thus, the sloshing effect in a tanker need to be taken seriously. The second literature review relates to the design of baffle in a tanker. O.M. Qureshi et al. In 2020 states that baffle act as partial barriers inside tanks to prevent liquid slosh and surge during the movement of the vehicle. Figure 6 shows the liquid movement restricted by the presence of baffle in the tanker. Study by BT and TKR Rajagopal in 2021 stated that the placement of baffle must be near the free surface level to effectively suppress sloshing effect. Free surface level is the surface on the uppermost part of liquid as illustrated in figure 7. Finally, 2 studies on baffle by A. Josh and I.H. Cho in 2020 and 2022 stated that porosity in baffle plays a major role in energy dissipation. They found that the porosity value of 0.1375 is the optimal design of vertical porous baffle. Porous, in simple words, is holes as shown in figure 8. Continue on to the next slide. Lloyd et al. In 2002 stated that perforated baffle reduce liquid slosh most effectively in a partially filled tank as compared to the other baffle design in the study, which are solid dish, oblique, spiral, round, and perforated baffle as shown in figure 9. Design of rectangular baffles in the FRT's water tank need to be reviewed. Currently, there are two 2 mm thickness of stainless steel horizontal rectangular baffles located approximately 1.1 meter from the deepest part of the tank and 9 to 1 mm into each other. Thus, the problem need to be addressed is the porosity and its configuration. There are three objectives for this study, which are to identify design parameters of baffles in the FRT water tanks, to design suitable baffles for FRT water tank based on the identified design parameters, to analyze the effect of baffles toward the FRT water tank using CFD application. Scope and limitation for this study are as below. Review baffle design of FRT scanner P310. Four variables that will be involved are no baffle, current baffle, 2 porous baffle, 3 porous baffle. 3 samples will be made which involve different configuration of baffles. Porosity that will be used are a value of 0.1375. CFD analysis conducted in SolidWorks flow simulation. Lastly, determine the best design for max energy dissipation. Process flow on this study involves 4 phases. In phase 1, initial study, which is the root of the study, involves literature survey, information gathering and analysis the causes of water leakage. Secondly, phase 2 involves CAD model development. In this phase, CAD model of the FRT's water tank and horizontal baffle is built in SolidWorks software. Figure 11 shows the CAD model of the FRT water tank. Next, phase 3. CFD analysis will be made in SolidWorks flow simulation by importing parameters for different variables. Finally, analysis of result is the final phase of this methodology. It involves data management, analysis, and conclusion of results. Expected results for this study will be the outcome of CFD analysis. Vorticity formation can be obtained from the liquid slosh from CFD analysis of a partially filled tank as in Figure 12. Then, acquire horizontal and a moment response to the tank wall and compare the results of all variables as shown in Figure 13 and Figure 14 respectively. This is the project planning for my final year project. This is the Gantt chart for FYP1. Gold color indicates planning and green color indicates actual. The planning activities in FYP1 are topic search, information gathering, introduction, which includes literature review, problem statement, and objective, scope and limitation, then build CAD model, methodology, early or expected results, and final presentation. Lastly, this is the Gantt chart for FYP2. The planning activities in FYP2 are completing CFD simulation, then do result analysis, technical report documentation, thesis documentation, preparation of FYP2 presentation, and technical report and thesis submission. This is my references for this study. That's all from me. Thank you for listening. If you have any question, you can contact me as information below. Assalamualaikum.